This is the next video in the chapter on composition of solutions. We just spent a quality amount of time discussing molarity and how to do a dilution, but molarity is not the only way that we measure concentration. So we're going to introduce a few other ways to measure concentration: mass percent, volume percent, mixed percent, and parts per million and parts per billion. So first, a summary statement. Molarity is the most common way to measure concentration because it's by moles. It's a way of measuring it by the number of atoms in the solution, which is particularly useful for chemists. So molarity is the most common concentration measurement in chemistry, but other people don't always care about how many atoms are in a solution, especially in industry. So in industry and in the medical field and out in the world, other units exist. And we need to go over those so that you are properly equipped to interpret what it says on your cereal boxes and bleach bottles and whatever other consumer products you may be using. So we'll start with mass percent. So mass percent can also be listed with the units percent without any information, or it might say something like W/W percent for weight percent. And mass percent is a measurement of mass in parts per hundred. That's the cent in percent is for 100. And the formula for mass percent, or percent by mass, is we take the mass of the solute, we divide it by the mass of the solution, the whole thing. And if we were to stop right here, this part would be called the mass ratio. So the ratio of the mass of one part to the mass of the whole thing. But this isn't called the mass ratio, this is called the mass percent. And the percent is a parts per hundred. So we multiply this by 100. And I'm emphasizing this seemingly obvious fact because it will be useful for one of the other units later. And the most important thing you do when you make this ratio is that you can choose whatever unit for mass you want, but you need to choose the same unit, or the top and the bottom. Units should match so they cancel out. Because the only unit in this is percent. So they need to have the same unit in the ratio. Okay, so we can make a ratio of masses. We can also make a ratio of volumes. And sometimes you see volume percent listed as V/V percent, or volume per volume. So percent by volume is the ratio of the volume of one of the pieces over the volume of the entire solution. So we could consider that our volume ratio, volume to volume, and because it's in parts per hundred, that's what the percent means, parts per hundred. We take our ratio and we multiply it by 100. Okay, so far so good. These are probably things that you've seen before in life on consumer products in your house. Now we're going to move on to the weird one, which is mixed percent. So mixed percentages are where you have different quantities on the top and the bottom. Usually when we see this, it is a mass volume percent. So a mass on the top and a volume on the bottom. So sometimes it's written as M/V percent. Usually it's not written as anything. Usually it doesn't even have a unit at the end. So these are going to be discipline-specific numbers, and you are going to want to know for absolute sure what units your discipline usually uses, because the units don't cancel out in this case. So a mass volume percent is the mass of the solute, usually in grams, over the volume of the solution, usually in milliliters. Not always, because this is a super weird unit, but that's the most common one that I've seen. And then multiplied by its 100, because it is a parts per 100%. So the most common time that we see this unit is in the medical and pharmaceutical fields. It's used to measure the concentration of saline solutions, for example, or of blood insulin levels. So for example, if you might see nurses using a 0.9% saline solution. And this means that there is 0.9 grams of sodium chloride salt per 100 milliliters of solution. So I would consider it to be a little bit misleading because I always assume that the unit on the top and the bottom are the same, if not specified. So yeah, medical people, watch out for that. Final set of units is parts per million and parts per billion. And this is parts per million by mass, to be specific. So this is basically just another version of mass percent, and except instead of multiplying by 100 to get parts per 100, we're going to multiply by a million or a billion to get parts per million or parts per billion. So it seems like a weird unit unless you think of it in context of percent as being parts per 100. So parts per million is going to be that same mass ratio, the mass of the solute over the mass of the solution. Mass ratio. Except this time, instead of multiplying it by parts per 100, we're going to multiply it by 10 to the 6th, a million. Because the concentration is so small that we need to multiply it by a huge number to make it an easier number to work with. Because nobody wants to tell their friend, oh, the concentration of that is 0.0000005. That's really useful. Much more useful to express it like this. Okay, and parts per billion is for even less concentrated by mass. So the mass of the solution, solute, mass of solute over mass of solution. That is our mass ratio, and we're going to take that mass ratio, which is a very, very, very small number, and multiply it by 10 to the 9th, by a billion, to make it a little bit larger so that number is easier to talk about. And these numbers can be a little bit tricky to use in context, so I want to add one more note here to help you use them. So if you are trying to find a number in parts per million, the question says, how many parts per million is this thing? You're going to want to calculate the mass ratio first. So the ratio of the mass of one part to the mass of the entire thing. Then you'll multiply by 10 to the 6th. That will give you parts per million, or 10 to the 9th for parts per billion. When you want to use this number, you use it a little bit differently. You do sort of the opposite process. So you take your parts per million, which will be like 5 or 7, and you'll divide it by a million first, giving you that really, really small mass ratio back. And then once you have the mass ratio, then your number is ready to use. So in the next video, we will do a series of examples using these 1, 2, 3, 4, 5-ish other concentration units plus molarity, and show how to use them in the context of a word problem.